My name is Colton. I'm an application engineer at Stratasys, and we're going to be looking at this Kinetic Vision cup. This is one in a series of videos for this cup, and this one I believe is going to be the longest one, is actually talking about considerations before importing your part into KeyShot. And the first one we're talking about is solid bodies. Each part that you import into KeyShot should start out as a solid body. It should have volume to it. If it's just a surface, then the printer is not going to know where to stop printing the material. It won't know where the ends of that part are. So that's the first one we're going to look at. I'm going to show, we're going to talk about the things we're going to be talking about, and then we'll actually go look at them in SolidWorks and in KeyShot. And this applies to any CAD software you're starting out in. For us, it's in SolidWorks. We're also going to talk about overlapping bodies. On these two cups, they are both rendered in KeyShot on screen. On the left one, you can't see the liquid below the surface. And that's because the edge of the liquid and the edge of the cup are perfectly mating each other. When that happens in KeyShot, sometimes you can't see that next material. So the one on the right is overlapping. There's a little overlap between the liquid and the glass. They are on top of each other. And that's here in SolidWorks. You can see they're just up next to each other or they're overlapping. There's an alternative to designing that way. Instead, you could just scale up the liquid in KeyShot. So you can design normally, and then in KeyShot, take that liquid and scale it up by a small amount in the horizontal directions so that it overlaps. The next thing we're going to talk about is polishing layer. Polishing layer is adding some clear material to the outside of your part. And that, or not just the outside, but the areas where you're going to sand it most. And that means that when you sand away the surface texture, getting ready to clear coat your part, you're not going to sand away any of the color. You're only sanding away this extra clear material until you work your way down to the original geometry size. For this cup, we're going to add it manually. So this orange layer on the outside of the cup, that is the polishing layer. We're only going to be sanding the outside of the cup and the bottom. We're not going to be sanding the liquid surface or the threads there. We could do it automatically through GrabCAD, not with this cup, but with other geometries, other applications. This wine bottle is printed with an automatic polishing layer in GrabCAD. Here on the assembly layer, or if it's not assembly, just a part layer, there's an option for a polishing layer. We need clear material loaded in the printer, and it needs to be printed in matte. Then you can adjust this from 0.35 to 0.6 millimeters. That worked great for this wine bottle. It does not work great for this cup, because if we added that thickness to these threads, then the lid would not be able to screw on and off. Then we're also going to be talking about Underprint in this video. Underprint is a process used in the manufacturing world where printing on clear labels, you can print white first and then print color on top of it. And that means your print is going to be opaque. It's going to pop better. It won't be semi-transparent. And in this case, we want this graphic on the top to be that way, but this red circle on the bottom, we want to look red from the bottom and from the top of the cup. And actually, it's mostly designed so when you look at the front of the cup, you can see that red reflection. So if we had white printed on the top or the inside of that red circle, we would not get that effect. The designers specify they want white underprint here. They even provide us with a picture to show where that should be. And that is just under all the fruit for that graphic. Underprint can also be assigned automatically in GrabCAD Print. This wine bottle, another great example of white underprint. We just wanted all the colors to have underprint for this bottle, so we turned on white underprint there. We did not need to make a separate shell for that white underprint. We want that underprint to start exactly where the color shell ends. That's going to change depending on your material setup. Assuming you have ultra white, ultra black. If you have ultra black, it's going to be 0.5 millimeters. That's how thick the color shell is going to be. If you don't have black, and the reason this would be is if you're running a J55 without black, because you have clear, then your color layer is going to be 1 millimeter thick. So we'd want the underprint layer, other underprint shell, to be 1 millimeter into the part. We're going to start by looking at the solid bodies. And this is a file that was provided by the designers. What we can do is look at a section view of this file. So if I cut it in half, we can actually see inside of this part. We can see through it. And that's a sign that this is just a surface model. It's not actually a solid body. And the issue with that is that the top of this liquid, the side of the liquid, and the side of the cup, we can't possibly combine those in different ways to make a solid body. Now the window for the lid, that is a solid body. That part looks great. Here in KeyShot, I open that SolidWorks file. We can see that it has many more parts than intended. There should be the liquid, the cup, the lid, and the lid's window. But there's many more than that. We can actually hide these and look at how, well, that's not a solid body. That's definitely just a surface. We can look at this in GrabCAD Print as well, and I'll show you a great check you can do in GrabCAD. Here is that same cup from KeyShot now opened in GrabCAD as a 3MF file. And this check is quick, it's easy, and it applies to any assembly, not just assemblies coming from KeyShot. And the check is to change this assembly from assembled to disassembled, just to check it. We can see here that these two things, these two surfaces, actually should go together and form one part. They need to be printed together. And GrabCAD thinks they're two different parts. And that's because in SolidWorks, where we started, they were two different surfaces. Didn't know those should go together. And then the same thing here, where we have the top of the liquid, we have the side of the liquid, and then an open cup, and then the, there's no way to put those things together to make a part. So this is why this matters. If we were to fix this, I'll show you in a second, it's actually going to close these off and not give us what we want. So now it repaired those models best it could, and it took this cup and actually zoop, cut off the top, or it sealed it in, closed it off. It closed that hole, because GrabCAD is really great at fixing files. It will close holes for you, which is great, except this file was nowhere close to start with. So we got a totally solid cup instead of having to go down to the liquid level. So that's why it's important we start with solid surfaces. In SolidWorks, you can check for solid surfaces or even fix them. I took that file we got from the designers and I use a Stitch Surfaces tool. So this guy here, use that Stitch or Knit Surface tool to select different surfaces and say these really belong as one body. And now I can do section view and see that I see a solid part. I don't see through it to that surface. This is the next version of my SolidWorks file that actually has the polishing layer and the white underprint layer built in as well. So if I do a section view of this, I can see that on the edge here, and I made the material for this transparent, so you can just see the outline of it. This is my polishing layer. It is on the surfaces where I'm going to sand. So it comes down to the bottom. It's not on the inside. And that is, I think I made it 0.5 millimeter thick. Depending on how aggressively you sand, or what risk tolerance you want to take, you can make it thinner or thicker. This orange area is my white underprint. So here we can see the threads. This is the outside of the cup. The color label is going to be applied to this part. And then inside of there is the underprint. So this is offset by 0.5 millimeter into the cup. We can also see down here the offset liquid. So this is the inside of the cup that's semi-transparent there, and then the liquid is actually extending into it a little bit, and that's going to make KeyShot render appropriately while keeping all those surfaces intact. Now, with a new KeyShot project, we can check out that file. I'm going to specify the up orientation is Y, because that's how SolidWorks does it. If you preset that to be the right orientation for your CAD software, it's going to save you a step. Click import, and then it'll bring in our part. Now when this part comes in, I would actually want to check this again, and I'm going to use the Flip Normals tool to check these parts. I recommend going through and checking every part that comes in to make sure the normals are facing the correct way, and it's also going to be a good tool to check that you're dealing with solids and not with surfaces. You could even hide these and show them one at a time and check them that way. Yep, that looks good. Flip Normals. Yep, that looks good. If it is not, if the normals are not correct, you'll actually see some red areas, and that's going to be where the normals are backwards. Normal is telling the software which side of a triangle is inside and which one is outside of the model. So this one is a cup. This is where the graphics are going to be placed. And this one, we can see some red triangles here. So that should be the inside of the part. First step is click on Auto Align Normals. And now we see the outside of all the triangles. Perfect. Then click Apply. So that's why we should go through each part and check that. Now, that's the end of this video. We now have solid bodies inside of KeyShot, and we can move on to the next step, which is going to be subgroups and renaming our parts.